simple harmonic motion, which as the name suggests is just a very simple type of motion. It's simply this. A particle just goes backwards and forwards between 2 points, essentially, but in such a way that its acceleration is directly proportional to its distance from some fixed point, so the centre of the motion. So it's basically saying this: the acceleration is proportional to displacement. Well, if that's true, then we know it's equal to some constant times the displacement. But the thing is, we need that constant to be a negative number in order to make the motion work. So rather than saying constant times x, we say minus n squared x, and then that makes sure that that constant is negative. Particle undergoes simple harmonic motion, then that's the rule it obeys. If we ever have to prove something's in simple harmonic motion, that's what we have to prove. That acceleration is equal to some negative constant times the displacement. Okay, let's use that then to create some other equations. Acceleration, I've got it in terms of x, so v to v dx is minus n squared x. Separate out the variables. Now, I've made it a definite integral. Where did I get these numbers from? Think about how I describe the motion. It's just going backwards and forwards between 2 points. So what do I know for sure? I know that when it's at the end point, it must stop so it can come back. So that's what I'm saying here. I'm saying A is going to be the end point of the motion, amplitude if you like, and at that point velocity will be 0, and from this I will work out a relationship between velocity and displacement. So I'll integrate both sides, substitute in, and I get this expression. I can keep going. V will be plus or minus n times the square root. Now, at this point, I can just prove about that path, or show something about that path. Remember that idea, v squared is going to be greater than or equal to 0, or essentially what's under the square root sign. So really, I just need a squared minus x squared is greater than or equal to 0. If I solve that, well, there you go. There's the motion. It's going backwards and forwards between a and minus a. Alright, let's keep going. Let's try and find the displacement equation. So now I'll say velocity is equal to, and I need to make a decision now, is it plus or is it minus? But actually I could take either one for this one and satisfy those initial conditions. Because remember, my initial condition was when x equals a, velocity equals 0. Well, it doesn't matter whether it's plus or minus, it's going to be 0. Why did I choose minus? I'm looking ahead to what I'm going to get. When I integrate, I'm going to end up with an inverse cos or an inverse sine function. Now I've chosen inverse cos. That's where I want to go. Why? Because I'm trying to match the motion. Look, I'm going backwards and forwards between 2 points. Of all the functions we know, what function does that? And that's our sine curve and our cosine curve. So essentially they're going to end up being either a sine curve or a cosine curve. My problem I just put together was I used the initial condition that when it was at its end point, or its amplitude. Well, which curve out of sine and cosine starts at the amplitude? The cosine curve. I just want to make life easier for myself. So that's why I've chosen it. So when I integrate this one, I'll get inverse cos, and I'll create a cosine curve rather than a sine curve. There we are. Substitute in, and I get a nice neat formula. Well, that's t in terms of x. I want x in terms of t. Play around with it, and there it is. X is just equal to a cos nt. It matches the motion. What does a cosine curve do? It goes up and down between a and minus a, and that's what my motion's doing. I could have chosen sine, but there'd be some sort of shift happening, of course, to make it the motion fit in. So it makes life easier. So in general, we know that. That'll be our starting point in a lot of cases, or it might be what we're being asked to prove. We will end up with this. Now, this is not something we quote. There's not one formula, but we'll get there. But that stage allows me to get the path of the particle once I've got it at v squared. And then I'll end up with either cos or sine. Again, I'm going to pick the one that matches my motion. If I'm starting at the centre, then I'll go with the sine curve rather than the cosine curve. Now, this particle has period. Well, it's still period. It's a trig curve, 2 pi on n. But the other thing we talk about is frequency. And all frequency is the reciprocal of the period. Because period is basically saying how long does it take for one oscillation. So go backwards and forwards. Whereas frequency is saying how many oscillations are there per time period. So one's the reciprocal of the other. So let's look at some examples then. We've been told that they've given me the displacement equation in this case. So x equals 4 sine 3t. Prove that it's simple harmonic motion. I just got to differentiate it a couple of times and I can go, oh yeah, look, that is a negative constant times the displacement. That's what we recognise to be simple harmonic motion. That is simple harmonic motion. The period, 2 pi on 3. 2 pi on n in our case would be 3. Find the interval the particle moves. This is where we use two ideas. We have calculus that can help us, but our knowledge of trig functions can help us, and that's going to be quicker because we've got a displacement equation there. It's a sine curve. We know it goes between 4 and minus 4. That's what this particle's doing. So I can just write it down. Its greatest speed, well, look at the velocity equation. It's a cosine curve. The biggest that's ever going to be will be 12. There's my answer. Okay, acceleration is minus 4x. They've given us some initial conditions. Find the interval in which the particle moves and then go and determine the greatest acceleration. So v to v dx is minus 4x. Separate out my variables. My initial conditions was, there it is, x equals 3, velocity is 6. So we do some integration. Bang, there's that v squared formula. We want to find the interval. Well, that's where we now use the fact that, hang on, that's got to be positive. Bang, I've got the path of the particle. It's going in between minus 3 root 2 and 3 root 2. Greatest acceleration, I can now just write down essentially, because of the nature, acceleration is a multiple of displacement. So the greatest acceleration must happen at the greatest displacement, or actually technically the minimum displacement because it'll be the negative. But anyway, the number's more and more interested in 12 root 2. This one was nice. There's the displacement equation, and it might not immediately be obvious that that's simple harmonic motion, but it is. And they want us to prove it, that we can get it into that form. Yes, it's simple harmonic motion, but with some shift happening there. I can combine those two trig functions into one trig function. See, the angle's the same there. They're both 2t. What would that be? The hypotenuse would be 10, and the angle would be the inverse tan of 3/4. And it's important that I use radians here, because I'm going to be performing calculus on the trig function. And anytime we do calculus and trig, for the calculus to work, the angle measure has to be radians. Different to projectile motion. In projectile motion, we had trig functions in it, but we weren't actually differentiating the trig function in that one. That was just a constant. So we could use degrees, that was fine. But here, I need to use radians. We end up with 5 plus 10 sine 2t plus alpha. I can rearrange it. I'll leave it as alpha. I know alpha is the inverse tan of 3/4 when I want to use it in my calculations. Differentiate it once, differentiate it twice, and I can get it into the required form. It is minus 4 times the displacement. Now I've said in the form minus n squared x rather than minus n squared x minus c, because look, at the end of the day, that constant is just a shift. The key is the coefficient of x. It needs to be some negative multiple of the displacement. When is the displacement of the particle 0 for the first time? Well, we're just solving a trig equation now. We've got an equation for displacement. So sine 2t plus alpha has to be negative 1/2. I just want the first positive solution, because we're assuming time's positive, the first positive solution of this. And that turns out to be, there we go, 1.5108. About 1.5 seconds for that one. So remember, simple harmonic motion, we're just going between 2 points. But what do we know? Out at the amplitude, that's when velocity is 0, because you've got to stop, but that's when acceleration will be at its maximum, as opposed to the centre of the motion, and that's when acceleration will be 0, but velocity will be at the maximum. Okay, something a bit more recent. Particle undergoing simple harmonic motion, period pi on 3. The central point of motion of the particle is x equals root 3. We know it has maximum displacement of 2 root 3 from the central point of motion. Find an equation for the displacement. I'll draw a little picture of what's happening here to get my head around it. I know the centre of the motion is root 3. Okay. But the amplitude, if you like, is 2 root 3, so I know it goes out to 3 root 3, back down here to minus root 3. Nice thing now in our HSC is that reference sheet. And on the reference sheet, they give us the simple harmonic motion formulas. And we can just quote it and say, look, I know it's going to be of this form. A cos nt plus C. I just got to work out what A is, N is, and C is. And they've given me enough information in this question to get that. Because they told me the period was pi on 3. So N equals 6. Got that. I know the shift is root 3. Now that's C. That's what C represents in this formula. It's the shift. C is root 3. And the amplitude, as I said before, is 2 root 3. So subbing that in, we get our equation for displacement. 2 root 3 cos 6t plus root 3. How about this one then? Simple harmonic motion. This time they've given me the acceleration question. They've given us some initial conditions. Between which two values is the particle oscillating? So in other words, find the path of the particle. Okay, you've given me that. V to V dx, separate out the variables, substitute in those initial conditions. We can do some integration, and there's our V squared expression. They want the path of the particle. We'll solve this in equation. And there we go. I'm going in between -2 and 8. Find the first value of t for which x is 0 to 2 decimal places. This is where I'm now going to make use of the reference sheet. They're telling us that is the form of simple harmonic motion, minus n squared x minus c. From all the information they've given me, I can work out that n is 2. Where's that? Right, because they told me it was -4 x minus 3. So n is 2, c is 3. But they've also told me that, hey, it's in the form x equals a cos nt plus alpha plus a constant. So from part A, we know the amplitude was 5. Total path is 10 there. Half of that's 5, or even the line above, it's telling us it's going between -5 and 5. Alpha, what's alpha? Sub in. T equals 0, x equals 11 on 2. So from this, we can work out alpha is pi on 3. There's the last piece of missing information we had for this problem. Now, when x equals 0, we can actually answer the question now. We solve this trig equation, and finally we got 0.58. It's a little bit more involved, that question, a bit more to do. Now let's finish off with this one. Okay, we've got 2 pistons. Oh, sorry, it's 1 piston, but 2 positions of the same piston. One when it's at its maximum height, one when it's at its minimum height. We're told the mass of our piston, and we know how many cycles it completes per second. What's the resultant force on the piston in newtons that produces the maximum acceleration of the piston? So this wasn't one of these scaffolded questions, it's one of these ones where you've got to put everything together and come up with the solution. So I'm going to draw myself a diagram. 0.17 was the maximum displacement. 0.05 was the minimum displacement. So in other words, I know my piston is moving between these 2 horizontal lines that I've drawn in. That gives me a total distance of 0.12 the piston's moving. But they told me it was simple harmonic motion, so I know the centre of that. 0.06 is the amplitude of my simple harmonic motion. I know the centre, therefore, is 0.11, the 0.05 plus the 0.06. So I now know the centre of the motion. They told me the frequency, but frequency is the reciprocal of period. So I now know the period, which allows me to find n. I've now got an expression for my simple harmonic motion. Acceleration will be minus n squared, 6,400 pi squared. X minus the centre of the motion was 0.11. Maximum acceleration we know will occur at the amplitude. I could substitute in either one of the 2. I went for the 0.05. So x is 0.05. There's the maximum acceleration, but they wanted the maximum resultant force. Force is mass times acceleration. There it is. The force of 3,032 newtons will produce the maximum acceleration of the piston. Okay, so a couple of exercises there on simple harmonic. 6B are ones that usually you start with the trig and then go and prove the simple harmonic motion, or you're told it is, whereas 6C is the other way around. It starts with the acceleration and